Hello everyone, good morning to all. Welcome to MGV's Arts, Commerce and Science College, Malagaon City, class FY semester 1st, Physics paper 2nd. Myself, Professor Firdaus Ara from Department of Physics, and in this lecture we will start our chapter number 4, Sources of Electromagnetic Waves. The important topics in this chapter are Introduction of Electromagnetic Waves. It covers the basic definition, various types, mode of propagation, their nature, what are actually electromagnetic waves. All these topics are covered in this. Then the brief history of electromagnetic waves. As we know that it is one of the greatest discovery in the field of physics. So how various scientists contribute for the discovery of electromagnetic waves, it is included in this topic. The third one is general properties of electromagnetic waves. Then the electromagnetic spectrum and its sources, because electromagnetic waves changes their property with wavelength and frequency. All these different types of electromagnetic waves or radiations are included in electromagnetic spectrum, and all can be produced by different sources. So this is included in the topic number 4. Next one is production of electromagnetic waves. How electromagnetic waves can be produced in laboratory for various purposes. Then the next important point is Planck's hypothesis of photon. After the discovery of electromagnetic waves, the Planck gives very important hypothesis about the electromagnetic radiation, which is about their dual nature. All the electromagnetic radiations have dual nature, that the first one is wave nature and the second one is particle nature, which is in the form of photons of energy h nu. And the last important topic is about the applications of various electromagnetic radiations like x-rays, ultraviolet, infrared, visible light, radio waves. All these have different applications in different fields, which is included in this point. Okay, so let's start. The first one is about the basic introduction about the electromagnetic radiation. In our daily life we very oftenly use the term electromagnetic radiations. Electromagnetic radiations appear and involved widely in our, not only in our world but in the whole universe also. We very commonly use the term radiations, but what they actually mean? For the most commonly we use the solar radiation. By the solar radiation we mean that the energy that come from the sun. When we stand in sun radiation, we feel heat, we feel light. All these are form of energy. The next important concept of radiation is used in wireless communication. In this communication we transfer signals which are actually energy from one station to another station through electromagnetic waves. And this wireless communication is one of the most growing technology of today's world. Without this, all our systems gone to become fail. Computers, satellite, cell phones, all these are depend on this wireless communication. And the basic idea behind this wireless communication is electromagnetic radiations. Another is x-rays. X-rays we commonly used in medical equipments, radio and TV signals. All these are somehow depend on electromagnetic waves or radiation for their application. So actually the electromagnetic radiation are the different forms of energy which can be transferred from one place to another place through electromagnetic waves. If we take very common example of solar radiation, then sun is the greatest source of energy on our world, and it radiates energy continuously in the form of various electromagnetic radiations. These electromagnetic radiations may be ultraviolet radiation, visible radiation, infrared radiation, all these. And these radiation from the sun comes to the earth in the form of electromagnetic waves. So electromagnetic waves are all electromagnetic waves So electromagnetic waves are the mode of transfer of energy from one place to another place. In wireless communication, X-rays, radio, TV signals, all these are another examples of electromagnetic waves. Okay, so we can define the electromagnetic waves as linked electric and magnetic field that travels in a medium or without any medium with velocity 3 into 10 raised to 8 meter per second. Okay, so electromagnetic, the name itself indicate that there are two components, electric field component and magnetic field component, and these components are linked with each other. So in the figure it will be cleared that the electromagnetic waves has electric field vibrating in one direction and magnetic field vibrating in another direction perpendicular to the direction of propagation. So every electromagnetic waves has two components. First is electric field component and second one is magnetic field component, hence they are given the name electromagnetic. And the point here to remember is that these electric and magnetic components are not independent but they are linked with each other. Okay, so this is about the electromagnetic waves. Electromagnetic waves are essentially the mode of transfer of electromagnetic energy. Electromagnetic energy means energy in the form of electric field vectors and energy in the form of magnetic field vectors, and they are transferred through the space, require medium or not any medium, from one place to another place through electromagnetic waves. Now the point here to clear is that why they do not require any medium. The answer to this question is found after long time by the discovery of electromagnetic waves, is that electric field and magnetic field can exist in the region where there is a no matter present. So for the propagation of electromagnetic waves we do not require any material मीडियम. जब इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड को ही कोई मीडियम रिक्वायरमेंट नहीं है उनके प्रोडक्शन के लिए या उनके प्रोपगेशन के लिए, तो इलेक्ट्रोमैग्नेटिक वेव विच इज़ composed of only these two components does not require any material medium. If medium is present then it can travel, if medium is not present then it can travel. So medium is not the requirement for the propagation of electromagnetic waves. It is very much important property of electromagnetic waves, because we will study the another two types of waves, longitudinal and transverse waves. Here the basic requirement is the presence of medium, but the discovery of electromagnetic waves problem is solved by the discovery of electromagnetic waves, है ना. Various examples of electromagnetic waves is most important visible light. Out of all the electromagnetic waves our eye can sense only the small range of electromagnetic radiation which is visible light. Other are ultraviolet, infrared, x-rays, radio waves, microwaves. All these are various types of electromagnetic waves, and electromagnetic waves consist of electric field and magnetic field components perpendicular to each other and also perpendicular to the direction of propagation. Now the next important point about the electromagnetic waves is their history, how they discovered. When we talk about their discovery, then the three scientists play a very important role in the discovery of electromagnetic waves. The first one is Charles Coulomb, second one is Michael Faraday, and third one is James Maxwell. Charles Coulomb, it gives the basic idea about the electrostatic force, that is any two charges they either attract each other or either repel each other. This force is known as electrostatic force. Then the two important scientists Faraday and James Maxwell, all the credit of discovery of electromagnetic waves goes to both of them. First, the Michael Faraday gives the very important law of electromagnetic induction. Electromagnetic induction tells that the changing electric field can produce the magnetic field or vice versa. Means if we can change either electric field or magnetic field, then we can get the second field. That is, if we change electric field, we can get magnetic field, and if we change the magnetic field, we can get the electric field. This is very important डिस्कवरी बिहाइंड द इलेक्ट्रोमैग्नेटिक वेव्स, है ना. यहाँ पे फिगर जो आपको नज़र आ रही है, दिस इज अबाउट द इलेक्ट्रोमैग्नेटिक इंडक्शन. इट कंटेन वन सोलेनॉइड and one magnet is moving continuously inside and outside the solenoid. Due to this, the magnetic flux or magnetic field linked with the solenoid changes continuously, and as a result of this changing magnetic flux, there is a production of electric field, and due to this, current flow in the external circuit, which is sensed by the galvanometer. So this is about the overall idea about electromagnetic induction. Here we change the magnetic field. The reverse process is also possible. That is, if we change the electric field through a circuit, then there is a production of magnetic field. Okay, and the third important scientist which unified the electric and magnetic field phenomena, it is James Maxwell. It tells us that the time varying electric and time varying magnetic field are the important sources of production of electromagnetic waves. And how this can be done? This can be done by any accelerated charge particle that produces electromagnetic waves. First, there is a presence of charged particle, and every charged particle produces an electric field around it. So we can get electric field. One component we get. Okay, when we accelerate this charge particle, accelerate कर रहे means इसको हम move कर रहे हैं, and due to the motion of charge particle we get an electric current. Now here the phenomenon of Oersted comes, that any current through conductor produces magnetic field around it. So due to this acceleration of charge, we get the next important component of electromagnetic wave, that is magnetic field. So charge particle already gives electric field. Due to its acceleration, we get magnetic field, and both these fields are interdependent, or in other words we say that they are linked, and linked electric and magnetic fields are known as electromagnetic waves. So this is the most simplest concept of production of electromagnetic waves, that simply take a charge particle, it always produces electric field around itself, then accelerate the charge particle. Due to acceleration, it gives current, and current always produces magnetic field around it. So we get the two components of electromagnetic waves, electric field component and magnetic field component, and their direction is always perpendicular to each other. We can determine direction by the three rules: right hand and thumb rule, Fleming's left hand rule, and Fleming's right hand rule. There is no need to revise because we have already studied all these rules in previous standards. So point here to remember is that any accelerated charge particle can produce electromagnetic waves. Okay. So how can we actually define the electromagnetic wave? An electromagnetic wave is a mode of transfer of electric and magnetic energy. ओके, एक्चुअली वेव का काम ही यही होता है कि वो एनर्जी को एक जगह से दूसरी जगह पर ट्रांसफ़र करे. इलेक्ट्रोमैग्नेटिक वेव में एनर्जी मोस्टली इन द फॉर्म ऑफ इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड, एंड बोथ दीज एनर्जी कंट्रीब्यूट्स ए पर्टिकुलर सिग्नल. जो हम सिग्नल की बात करते हैं कि सिग्नल ट्रांसफ़र करना है, तो सिग्नल में दो कंपोनेंट्स होते हैं, इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड, और इनको जो वायरलेस कम्युनिकेशन से हम ट्रांसफ़र करते हैं फ्रॉम वन प्लेस, जहाँ से ट्रांसफ़र करते हैं उसको बोलते हैं ट्रांसमीटर, एंड जहाँ पर वो रिसीव करते हैं उसे कहते हैं रिसीवर. तो इन बिटवीन द ट्रांसमीटर एंड रिसीवर द सिग्नल इज ट्रेवल्ड और carried by electromagnetic wave. It should be cleared from the figure. Here an electromagnetic wave is shown which is traveled along the z direction. Okay. The electric field components and magnetic field components should always perpendicular to each other and also to the direction of propagation. So here electric field component is along the x direction, they vibrate along the x direction which is perpendicular to the z direction, and magnetic field components are along the y direction which is always perpendicular to z direction. So यहाँ से हमें क्या पता चला कि E which is electric field vector, B which is magnetic field vector are always perpendicular to each other and also should be perpendicular to the direction of propagation also. Okay, now these electric field and magnetic field constitute their own waves, है ना. So the electric field wave which is in the direction of x axis, okay, vibrate in the direction of x axis, it is given by Ex is equals to E0 sine kz minus omega t. E0 is the amplitude of electric field vector, z is the direction of propagation, t is time, and omega is the angular frequency. From here it is clear that they travel simple harmonically and they are time varying fields. Same for the magnetic field. It is in the y direction. So By is equals to B0 sine kz minus omega t, where B0 is the amplitude of magnetic field vector. Okay. And the K is very important regarding the electromagnetic waves. It is known as wave vector or propagation vector, and its value is always equals to 2 pi upon lambda. Lambda is the wavelength of electromagnetic waves. So the propagation vector always play very important role in the propagation of electromagnetic waves. Next important point is also the velocity of electromagnetic wave. It is usually denoted by c, and this will be equal to omega upon k and can also be equal to 1 upon square root mu epsilon. Mu is the permeability of the medium and epsilon is the permittivity of the medium. Okay, so the velocity of electromagnetic wave in a particular medium depends on its permeability and its permittivity. Now 2 point important to remember: permeability always comes when there is a talk about magnetic field, and permittivity always comes when there is a discussion about electric field, and electromagnetic wave constitute all these two components. Hence both these permittivity and permeability are included in the equation of velocity of electromagnetic waves. So electromagnetic wave is a mode of transfer of electric and magnetic energy, and both these electric and magnetic fields are simple harmonic time varying waves. Okay, and their equation is given by these two equations. This is about the actual what are the electromagnetic waves. So electromagnetic waves are mode of transfer of energy. Now here some general properties of electromagnetic waves. Okay, first one is all electromagnetic waves travel with same speed through empty space called speed of light. Okay, in the vacuum where there is a no medium is present, all electromagnetic waves has same velocity, and this velocity is equal to the velocity of light or speed of light, because light is a form of electromagnetic radiation, and it should be clear that this is the maximum attainable velocity in the world or in the universe also. इससे ज़्यादा velocity attain करना now impossible. So electromagnetic wave की velocity always maximum होती है in the vacuum or empty space, and this will be equal to velocity of light which is denoted by c, and its value is 3 into 10 raised to 8 meter per second. Okay, Not only light but all the electromagnetic waves like radio waves, x-rays, all these travel with this speed in the empty space. When they come in medium, speed changes due to the permittivity or permeability of the medium. The second important property of electromagnetic wave is they does not require any material medium to travel, है ना. ये अभी हमने previously discuss किया कि for the propagation of any other type of wave the medium requirement is necessary, but for the propagation or travel of electromagnetic wave there is a no require of material medium. If there is a no medium, like in the vacuum there is a no medium present, but through vacuum electromagnetic waves can travel. सन से लेके अर्थ तक वैक्यूम है, जब अर्थ के एटमॉस्फेयर में इंटर होती है इलेक्ट्रोमैग्नेटिक वेव वहाँ पे मीडियम है, बट इन द वैक्यूम देयर इज अ नो मटेरियल मीडियम, बट स्टिल द सोलर रेडिएशन कम्स टू अर्थ. दिस इज द प्रूफ दैट दे डज नॉट रिक्वायर एनी मटेरियल मीडियम फॉर देयर ट्रेवल. एंड व्हाई दिस इज सो? बिकॉज इट इज मेनली composed of two components, electric field component and magnetic field component, and both these does not require any material medium for their propagation, for their production, for their travel. So overall electromagnetic wave does not require any material medium for their travel. It is the most important property of the electromagnetic waves. The third one is electromagnetic waves vary with wavelength and frequency. Okay, as we change the wavelength or frequency of the electromagnetic waves, their properties, their energy, all these changes, and due to this we get different types of electromagnetic radiations. Out of these we can see only the visible light. Okay, so as we vary the wavelength or frequency, as wavelength increases frequency decreases, or vice versa. So if we change one, the next one is automatically changes. So in electromagnetic wave, if we vary wavelength and frequency, then their properties changes. Based on this we have the large electromagnetic spectra. The next property is all the electromagnetic waves propagate in the form of time varying electric and magnetic fields. Okay, we have discussed this previously that each electromagnetic wave constitutes two components, electric field component and magnetic field component. Both are time varying and perpendicular to each other, and also perpendicular to the direction of propagation. The next important property is that electromagnetic waves are polarized. Polarization, it is the term that is most widely used for the electromagnetic waves or light usually. Okay, polarized mean when the electric field or magnetic field vectors travel only in, vibrate only in one particular direction. जैसे कि अभी हमने प्रीवियस फिगर में देखा था कि यहाँ पे जो इलेक्ट्रिक फील्ड वेक्टर्स हैं they travel strictly along the x-axis, so we can say that they are polarized in x-axis. Same for the magnetic field component. In this the magnetic field vectors vibrate strictly along the y direction, so we can say that they are polarized in y direction. So we can say that in electromagnetic waves all or both the components E and B components are polarized in one particular direction, and that direction should be perpendicular to the direction of propagation. And the last important point is energy is distributed equally between E and B vectors. Okay, we have seen that the actually electromagnetic wave are the mode of transfer of energy from one place to another place, and this energy is distributed equally between E and B component. Means both electric field and magnetic field components carry equal energy from one place to another place. So this is all about the electromagnetic waves, their basic introduction, their definition, their properties, and so we will end for today. In the next lecture we will discuss the electromagnetic spectrum and various electromagnetic waves that are included in electromagnetic spectrum. So thank you.